The size of a TVSS, or transient voltage surge suppressor, refers to its capacity measured in kiloamps per phase. This capacity indicates the maximum surge current the TVSS can safely divert without failing. Larger TVSS units possess higher capacities and are designed to protect larger electrical systems. A capacity selection guide typically recommends choosing a TVSS capacity based on the main breaker capacity, reflecting the maximum current the electrical system can handle. Matching the TVSS capacity to the main breaker capacity ensures adequate system protection. Internally, TVSS units usually contain metal oxide varistors, or MOVs, as the primary surge suppression components. MOV are semiconductor devices that divert excess voltage to ground. Repeated exposure to surge currents can degrade or cause MOV to fail over time. Some TVSS manufacturers offer a way to check the remaining percentage of protection capability. This percentage indicates the surge current the TVSS can still handle before failing. The guarantee period for a TVSS represents the manufacturer's assurance of complete electrical system protection for a specified number of years. Typically, larger TVSS units with higher capacities have longer guarantees due to containing more MOV or having a more robust design. Larger TVSS units with higher capacities can generally handle more surge current and have longer guarantees. This is because they incorporate more MOV in parallel, which increases their capacity and reduces the likelihood of failure. Selecting the appropriate TVSS depends on several factors, including the size and sensitivity of the equipment being protected, the facility's exposure to surges, and the applicable electrical codes and standards. Firstly, consider the equipment's sensitivity. Sensitive electronic devices such as computers, medical equipment, and industrial controls are more susceptible to damage from voltage surges. These devices require a higher level of protection than less sensitive equipment such as lighting and motors. Secondly, assess the facility's exposure to surges. Facilities located in areas with frequent lightning strikes or power grid instability are more likely to experience surges. These facilities require a TVSS with a higher surge current capacity. Thirdly, review the applicable electrical codes and standards. Electrical codes and standards such as the National Electrical Code, or NEC, provide guidelines for selecting and installing TVSS devices. These guidelines help to ensure that the TVSS is properly sized and installed for the application. The surge current capacity of a TVSS is the maximum amount of surge current that the device can safely divert without failing. Surge current capacity is measured in kiloamps. The appropriate surge current capacity for a TVSS depends on the size and sensitivity of the equipment being protected, the facility's exposure to surges, and the applicable electrical codes and standards. A TVSS should have a voltage protection rating, or volts protection rating, that is appropriate for the voltage of the electrical system being protected. The voltage protection rating is the maximum voltage that the TVSS will allow to pass through to the protected equipment. The voltage protection rating should be less than the maximum voltage that the protected equipment can withstand. TVSS devices are available with a variety of features such as surge counters, status indicators, and remote monitoring capabilities. Surge counters track the number of surges that the TVSS has diverted. Status indicators provide a visual indication of the TVSS's operational status. Remote monitoring capabilities allow users to remotely monitor the TVSS's performance. The installation location of a TVSS can affect its performance. TVSS devices should be installed as close as possible to the equipment being protected. This will minimize the length of the wiring between the TVSS and the protected equipment, which will reduce the amount of surge voltage that can reach the equipment. TVSS devices require regular maintenance to ensure that they are operating properly. Maintenance includes inspecting the TVSS for damage, testing the TVSS's surge protection capability, and replacing the TVSS if it is damaged or has reached the end of its service life. The lifespan of a TVSS depends on several factors, including the number of surges that it has diverted, the magnitude of the surges, and the operating environment. TVSS devices that are subjected to frequent or high magnitude surges will have a shorter lifespan than TVSS devices that are subjected to fewer or lower magnitude surges. TVSS devices that are operated in harsh environments such as high temperature or humidity will also have a shorter lifespan. Several different types of TVSS devices are available, including point-of-use TVSS devices, hardwired TVSS devices, and surge-protected devices, or SPDs. Point-of-use TVSS devices are designed to protect individual pieces of equipment. Hardwired TVSS devices are designed to protect entire electrical systems. Surge-protected devices are designed to protect against surges caused by lightning strikes. When selecting a TVSS, it is important to consider the specific needs of the application. Factors to consider include the size and sensitivity of the equipment being protected, the facility's exposure to surges, the applicable electrical codes and standards, the surge current capacity, the voltage protection rating, the features, the installation location, the maintenance requirements, and the lifespan. By considering these factors, it is possible to select a TVSS that will provide adequate protection for the equipment and electrical system. Metal oxide varistors, or MOVs, are a common component used in TVSS devices. MOV are voltage-dependent resistors that exhibit a high resistance at normal operating voltages and a low resistance at high voltages. When a surge occurs, the voltage across the MOV increases, causing the MOV to switch to a low resistance state. This allows the surge current to flow through the MOV and be diverted to ground, protecting the protected equipment from damage. MOV are available in a variety of voltage and current ratings. The appropriate voltage and current rating for an MOV depends on the voltage and current of the electrical system being protected. MOV are typically connected in parallel to increase the surge current capacity of the TVSS. The number of MOV connected in parallel depends on the desired surge current capacity. MOV are susceptible to degradation over time due to repeated exposure to surge currents. The degradation of an MOV can reduce its surge current capacity and increase its voltage protection rating. TVSS devices that use MOV typically include a status indicator that indicates the condition of the MOV. When the status indicator indicates that the MOV have degraded, the TVSS should be replaced. In addition to MOV, some TVSS devices also include other surge suppression components such as silicon avalanche diodes, or SADs, and gas discharge tubes, or GDTs. SAD are semiconductor devices that exhibit a very fast response time to voltage surges. GDT are gas-filled tubes that exhibit a very high resistance at normal operating voltages and a low resistance at high voltages. SAD and GDT are typically used in combination with MOV to provide enhanced surge protection. TVSS devices should be tested regularly to ensure that they are operating properly. Testing can be performed using a surge generator, which is a device that generates high voltage surges. The surge generator is used to apply a surge to the TVSS, and the TVSS's response is measured. The test results can be used to determine whether the TVSS is operating properly. TVSS devices should be installed by a qualified electrician. Installation should be performed in accordance with the applicable electrical codes and standards. Proper installation is essential to ensure that the TVSS provides adequate protection. Grounding is an important aspect of TVSS installation. The TVSS should be properly grounded to provide a low impedance path for surge currents to flow to ground. Improper grounding can reduce the effectiveness of the TVSS and can even create a safety hazard. TVSS devices should be inspected regularly for damage. Damage can be caused by surge currents, physical impact, or environmental factors. Damaged TVSS devices should be replaced immediately. TVSS technology is constantly evolving. New TVSS devices are being developed with improved performance and features. It is important to stay up to date on the latest TVSS technology to ensure that you are using the best possible surge protection. One area of development in TVSS technology is the use of silicon carbide, or CC, varistors. CC varistors offer several advantages over MOV, including higher surge current capacity, lower voltage protection rating, and longer lifespan. Another area of development in TVSS technology is the use of advanced surge monitoring systems. These systems can provide real-time information on the performance of the TVSS, allowing users to identify and address potential problems before they cause damage. The selection of a TVSS involves determining the appropriate surge current capacity, which is the maximum surge current that the TVSS can safely handle. It is determined by considering factors such as the service entrance size, the facility's geographical location, and the types of equipment being protected. The service entrance size is the maximum amount of current that can flow into the building. A larger service entrance will require a TVSS with a higher surge current capacity. Facilities located in areas with frequent lightning strikes or power grid instability are more likely to experience surges. These facilities will require a TVSS with a higher surge current capacity. Sensitive electronic devices are more susceptible to damage from voltage surges. These devices will require a TVSS with a higher surge current capacity. The voltage protection rating, or volts protection rating, of a TVSS is the maximum voltage that the TVSS will allow to pass through to the protected equipment. The volts protection rating should be less than the maximum voltage that the protected equipment can withstand. A lower volts protection rating provides better protection. TVSS devices are available with a variety of features, such as surge counters, status indicators, and remote monitoring capabilities. A surge counter tracks the number of surges that the TVSS has diverted. This information can be used to assess the facility's exposure to surges and to determine whether the TVSS is providing adequate protection. A status indicator provides a visual indication of the TVSS's operational status. This allows users to quickly identify any problems with the TVSS. Remote monitoring capabilities allow users to remotely monitor the TVSS's performance. This can be useful for facilities with multiple TVSS devices or for facilities that are located in remote areas. Proper installation of a TVSS is essential to ensure that it provides adequate protection. The TVSS should be installed by a qualified electrician in accordance with the manufacturer's instructions and the applicable electrical codes. The TVSS should be installed as close as possible to the equipment being protected. This will minimize the length of the wiring between the TVSS and the protected equipment, which will reduce the amount of surge voltage that can reach the equipment. The TVSS should be properly grounded. Proper grounding provides a low impedance path for surge currents to flow to ground, protecting the protected equipment from damage. TVSS devices require regular maintenance to ensure that they are operating properly. Maintenance includes inspecting the TVSS for damage, testing the TVSS's surge protection capability, and replacing the TVSS if it is damaged or has reached the end of its service life. The lifespan of a TVSS depends on factors such as the number of surges that it has diverted, the magnitude of the surges, and the operating environment. TVSS devices that are subjected to frequent or high-magnitude surges will have a shorter lifespan than TVSS devices that are subjected to fewer or lower-magnitude surges. TVSS devices that are operated in harsh environments will also have a shorter lifespan. When selecting a TVSS, it is important to consider the total cost of ownership. The total cost of ownership includes the initial purchase price, the installation cost, the maintenance cost, and the replacement cost. A TVSS with a higher initial purchase price may have a low total cost of ownership if it has a longer lifespan or requires less maintenance. It is important to choose a TVSS from a reputable manufacturer. Reputable manufacturers offer TVSS devices that are tested and certified to meet industry standards. They also offer warranties and technical support. Understanding the relationship between TVSS size, guarantees, and capacity is essential for selecting the appropriate surge protection device for your needs. Larger TVSS units with higher capacities generally offer longer guarantees due to their more robust construction and ability to handle more surge current. Consider the sensitivity of your equipment, the facility's exposure to surges, and relevant electrical codes to make an informed decision. Regular inspection and maintenance are crucial to ensure the ongoing effectiveness of your TVSS.